Most forestry, environmental science, or natural resource programs have a soil science requirement. If you haven't taken it, these are good classes. They tell you a lot about how the world works and give you a skill set for describing it. I'm going to give you a brief overview, very brief overview of the field. I'm expecting that most of you have taken a soil science class. This will serve as a little refresher, and if you haven't taken it yet, keep you in the conversation, give you enough information so you won't get lost. So soils are a combination of components of forests. And before I begin describing this material here, I should note that what I hope we can do here is think about soils as an extension of forests, and I will approach it that way. So back to soil. What is it? Well, it's a combination of the mineral or inorganic, the living biotic part of forests, roots and microbes, as well as the detritus, the dead organic matter. Soil is, like I say, both a material of geological origin, also biological as dead organic matter. It is essential for supporting plant growth, and it really is the foundation to terrestrial ecosystems. That's true whether you're thinking about forests or grasslands and so forth. Here's some things about soils, characteristics of soils that are important to how it works. Texture is probably the easiest to quantify and one of the most important physical characteristics of soils. Texture of soils influences water storage capacity and availability. It is a function of the distribution of the particles, the size of particles, and the distribution of the specifically of the inorganic component of soil. So you may have covered this already. The relative proportions of clay, silt, sand, and then rocks, things that are larger than sand, gravels, and so forth, have a strong influence on how much water is retained in soil, for how long, and how quickly water drains through that soil. You may already know this implicitly or so forth, or from your soil science class, but fine texture soils can hold more water because they have higher surface area, but they also can hold onto them so tightly that the water does not move very well through them. This is a function of the surface area of these physical particles. And then the last component of water, in particular water availability, is the amount of organic matter in these soils. Organic matter acts like a sponge and holds on to water. It's a very important component. You can describe this, and if you've been through this before, it's probably, you're probably nodding your head and maybe falling asleep, but the relative proportions, especially of sand, silt, and clay, determine a lot about how a soil will act, and specifically how much water, how strong water limitation will be as a function of soil characteristics. And this is just kind of acknowledging also that all three of these components of soil, the living, the dead, and the mineral, are all interacting, usually on a microscopic scale. They're all there together, and they're constantly interacting. So the other thing that is generally one of the first things to go over about soil science, one of the most basic things about it, is how do you get soil? What forms soil? And there are 5 factors of soil formation that are worth us covering quickly just to kind of get us all up to speed. And the first is parent material. That is referring to the inorganic sources of those sand, silt, and clay that's going to form the inorganic portion of mineral soil. So we've got Miriam Peak, a granite Sierra Peak here on the left, and then the slopes of Mount Tom on the right, which is a more higher concentration of mineral components in those soils. The parent material here influences the amounts of inorganic nutrients as well as potentially toxins. So you may be familiar with things like serpentine soils and how those are difficult places to grow, and that's in part because of their inorganic concentrations, especially of heavy metals. The next factor is climate, and it's especially important in very hot or very cold environments or very dry environments. Those environmental factors tend to slow the formation of soils. So this is photograph is looking out onto Anza Borrego near San Diego, a hot desert that has low rates of soil formation. And topography. Flat ground tends to accumulate soil. So here in this photograph, you can see the flat alluvial sediments in the valley bottoms here, whereas on the mountain slopes, which are steeper, soil moves downhill and it accumulates more slowly. It also accumulates more slowly at the tops of the peaks, which are rocky in this case, not only because they're cold, but simply also because they're just poor, sharp points are poor places to accumulate soil. And especially relevant to us are the organisms. And forests and forest trees have a strong influence on the formation of soils, both the inorganic component and particularly the organic component, the dead component of soils. And lastly is time. Here's this, this is the image of what the Hubble saw on the 28th of March. You can look up what the Hubble saw on any particular day, and this is the best way that I can think about to demonstrate a long period of time.